Next is question number 81, which says that the system of equations 3x plus y plus 2z equal to 6, xyz equal to minus 5 and 3xy plus 2yz plus 6xz equal to minus 1 has a solution xyz where xyz are integers, then the value of x plus z upon y is equal to. Now here, if I assume 3x equal to x1 and y equal to y1 and 2z equal to z1, then the first equation can be written as x1 plus y1 plus z1 is equal to 6, and the second equation can be written as multiplying it with 6, so we will get x1 into y1 into z1 will be equal to minus 30. Now similarly 3x is equal to x1, so we have x1 y1 plus y1 z1 plus z1 x1 equal to minus 1. So these are the three equations that are given here. So from here we can say that x1 y1 z1 are the roots of the equation t cube minus 6t square minus t plus 30 equal to 0. So here we can say that x1 y1 z1 are the roots of this equation, right? Now making the roots of this equation, we can write it equal to t minus 3 into t minus 5 into t plus 2 equal to 0, right? So the values of x1, y1 and z1 are 3, 5 and minus 2. Now as x, y, z are given to be integers, so the only possibility is that is 3x equal to x1 should be equal to 3 and 2z should be equal to minus 2 and y should be equal to 5. The only possibility is this. So from here we get that x is equal to 1, z is equal to minus 1 and y is equal to 5. So the value of x plus z upon y will be equal to 0, right? So the correct answer is option number 1. Question number 82. Here it is given that if equation x5 minus 10 times x raised to the power 4 plus ax cube plus bx square plus cx minus 32 equal to 0 has all positive real roots, then 2a plus b equals. Now here it is given that all the roots are positive. Let us assume the roots to be alpha, beta, gamma, delta and phi. So here we are given that the sum of the roots is given to be equal to minus b by a, that is 10, and the product of roots is given to be equal to 32, right? Now we know that here am is equal to gm, right? That is here alpha plus beta plus gamma plus delta plus phi upon 5 is equal to alpha, beta, gamma, delta, phi raised to the power 1 by 5, right? Here am is equal to gm, so we can say that all the roots are equal, hence all the roots are equal to 2, right? That is delta is equal to phi is equal to 2. Now we have to find the values of a and b, right? Now a will be equal to product taking 2 at a time with a positive sign, right? That is, now we have 5 roots here, so product taking 2 at a time means that 5c2 into alpha beta, which will be equal to 10 into alpha beta is equal to 4, so this is equal to 40. Similarly, value of b will be equal to minus of taking product of 3 at a time, that is 5c3 into alpha beta gamma, which will be equal to minus of 10 into alpha beta gamma will be equal to 8, which will be equal to minus 80. Now the value of 2a plus b will be equal to 80 minus 80, which will be equal to 0. So the correct answer is option number 1. Next is question number 83, which says that if a is equal to matrix 0 minus tan theta by 2, tan theta by 2 0, where theta is not equal to n pi, where n belongs to integers and b is given to be equal to a matrix cos theta minus sin theta cos theta, and identity matrix I is also given here, then the value of 2i upon cos theta plus 1 is equal to. Firstly, let's assume the value of tan theta by 2 equal to a. So now we can see that in most of the options I minus a term is given. So let's firstly find I minus a, which will be equal to 1 a minus a 1, right? I minus a will be equal to this. Now b can also be found in terms of a, which will be equal to cos theta can be written equal to 1 minus a square upon 1 plus a square, and minus sin theta can be written equal to minus 2a upon 1 plus a square. Similarly, it can be written equal to 2a upon 1 plus a square, 1 minus a square upon 1 plus a square. Now, finding the value of I minus a into b, it can be written equal to 1 a minus a 1 into b, taking 1 upon 1 plus a square common, we will get it equal to 1 minus a square minus 2a 1 minus a square. Now this can further be written equal to 1 minus a square plus 2a square, and here we will get minus 2a plus a minus a cube, and here I will get minus a plus a cube plus 2a, and in the fourth term we will get 2a square plus 1 minus a square into 1 upon 1 plus a square. Now solving this, we will get it equal to 1 minus a 1, right? Now this value can be written equal to I plus a, right? So we get that I minus a into b is equal to I plus a. Now let's further find the value of I minus a whole square into b, right? Which will be equal to I minus a into I plus a, right? Now this will be equal to matrix 1 minus a 1 into 1 a minus a 1, right? Now this is equal to 1 plus a square, a minus a, that is 0, and here we will get a minus a, that is again 0, and this will be 1 plus a square. Now this can be written equal to 1 plus a square taking common into I, right? Now this can be written equal to 1 plus a is tan theta by 2. So this is 1 plus tan square theta by 2, that is secant square theta by 2. So we can write it equal to I upon cos square theta by 2. So this can be written equal to 2i upon 1 plus cos theta, right? So the value of this is equal to I minus a whole square into b, that is given in option number 2. Next is question number 84, which says that the number of real and distinct values of x which satisfies the equation x raised to the power 2018 plus 1 into 1 plus x square plus x4 plus up till x raised to the power 2016 is equal to 2018 into x raised to the power 2017 is. Now dividing both sides by x raised to the power 2017, we will get x plus 1 upon x raised to the power 2017 into 1 plus x square plus x4 plus up till x raised to the power 2016 is equal to 2018. Now expanding this, we will get x plus x cube plus x5 plus up till x raised to the power 2017 plus 1 upon x raised to the power 2017 plus 1 upon x raised to the power 2015 plus up till 1 upon x cube plus 1 upon x is equal to 2018. Now clubbing the terms x and 1 by x plus x cube plus 1 by x cube plus up till x raised to the power 2017 plus 1 upon x raised to the power 2017 is equal to 2018. Now we know that x plus 1 by x is always greater than equal to 2 or it is less than equal to minus 2, and similarly the value of x cube plus 1 by x cube is also either greater than equal to 2 or less than equal to minus 2. So it will go up till x raised to the power 2017 plus 1 upon x raised to the power 2017 is also greater than equal to 2 or less than equal to minus 2. So we can see that the left hand side is either greater than equal to 2 times 1009 or it is less than equal to minus 2 into 1009, that is minus 2018. Now for this to be equal to 2018, all the individual terms should be equal to 2, right? Which is possible only when x is equal to 1. So this is the only solution, right? So the correct answer is option number 2. Next is question number 85, which says that 4 geometric means are inserted between 3 raised to the power 13 minus 1 and 3 raised to the power 13 plus 1. Now the product of these geometric means is, now let us say the given values are a equal to 3 raised to the power 13 minus 1 and let us say b is equal to 3 raised to the power 13 plus 1. Now in between a and b we have inserted 4 geometric means. Let us say they are G1, G2, G3, G4, right? And then we have b. Now G1 will be equal to AR, where R is the common ratio, and G2 will be equal to AR square, G3 is equal to AR cube, G4 is equal to AR4. Now the product of these geometric means will be equal to a raised to the power 4 into r raised to the power 4 plus 3 plus 2 plus 1, which will be equal to 10, right? Now this can be written equal to a square r5 whole raised to the power 2, which can further be written equal to a into ar5 whole raised to the power 2. Now we know that b will be equal to ar5, so this can be written equal to a into b whole square, right? So the answer of the given question will be equal to 3 raised to the power 13 minus 1 into 3 raised to the power 13 plus 1 whole square, right? So this is equal to a plus b into a minus b is a square minus b square, that is 3 raised to the power 26 minus 1 whole square, which will be equal to 3 raised to the power 52 plus 1 minus 2 times 3 raised to the power 26. So the correct answer of the question is option number